This is Foundations of Math and Pre-Calculus 10, Chapter 2.2, and we're going to look at Part 2. In Part 2, we're going to be looking at right rectangular prisms and how it's derived, and we can start by making a net. So what we want to do is unfold each one of these triangles out, and we get a net that looks like this. B2 corresponds with slant 2, and B1 corresponds with slant 1. And now that we've got the net, it's much easier to calculate the surface area. So the area of the base is simply B1 times B2. And the area of the top and bottom triangles are 2 times, because there's 2 triangles, and then we use half base times height. 2 divided by 2 is 1, so this simplifies to B1 S1. And similarly, for the 2 side triangles, we would have B2 S2. And the total surface area would be B1 B2 plus B1 S1 plus B2 S2. Now on a harder problem, it won't give you S1 or S2. Instead, it'll give you H. And if this is the case, we'll have to use Pythagorean to solve for them. And just to let you know, to calculate S1, this will be folded over this way to the top. S1 will look like a triangle with top view like this. That means our base is here, we have our height here, and then our hypotenuse is this. So B2 corresponds to S1 for the hypotenuse calculation. So we have H squared, B2 over 2 squared, and S1, and similarly for S2. So this is square root H squared plus B2 over 2 squared. This one is square root H squared plus B1 over 2 squared. So let's look at an example. Find the surface area in squared centimeters and in squared inches. And we'll start off with our squared centimeter case. Surface area equals, and it helps rewrite the formula, B1 B2 plus B1 S1 plus B2 S2. That way we know what we're substituting in. So we have 6 centimeters times 16.1 centimeters plus, we'll call this one B1 and S1. So we have 6 centimeters times 9 centimeters. And lastly, we'll call this B2 and S2. So we have 16.1 centimeters. I'm just going to leave the centimeters out just because I don't have room, and we have 5 centimeters. So this gives us 231 square centimeters. And this should be approximately. We take our 231 squared centimeters. We need to multiply this by 1 inch over 2.54 centimeters and squared. And this gives us approximately 35.8 inches squared. Let's do one more. And again, write it out. B1, B2 plus B1, S1 plus B2, S2. Again, we'll call this B1, S1, B2, S2. So we have 16 inches by 5 inches plus 16 inches by 6.5 inches plus 5 inches times 10 inches. And this will give us approximately 234 square inches. We take our 234 square inches. We need to multiply this by 2.54 centimeters over 1 inch squared. And this gives us approximately 1,510 square centimeters. Finally, let's take a look at composite objects. And the challenge is determining which surfaces are or are not included. Now, suppose we're painting a podium. And this is a large podium because it's 5 meters by 3 meters. Determine the surface area that requires paint. And let's assume that this is very expensive paint. So that makes it easier to determine what we need to paint or not. And you should justify your choices. So the bottom of the podium is only a meter high. So really, you're not going to be bending down to look underneath the podium. So we don't need to paint the bottom. And we don't need to paint the feet of the legs because they're touching the ground. So all we need to do is the lateral surface area of the legs. Also, we don't need to paint the tops of the legs either because they're actually touching the podium. Okay, here's where it gets a little bit trickier. We definitely need to paint the top of the podium. We need to paint the front. We need to paint the sides. And if it's expensive paint, we don't really need to paint the back because nobody's going to be sitting behind the podium. Okay, so now we can start with our calculations. The edge surface areas. So we have, this is 20 centimeters, but we need to convert this to meters. So there's 100 centimeters per meter. And we need to multiply this by this edge, and this edge. So that's 3 meters plus 5 meters plus 3 meters. And this is approximately, or actually it just equals 11 meters times 0.2 meters. And we should cancel out centimeters. And this gives us 2.2 square meters. Top of the podium, this is easy, 3 meters times 5 meters. This gives us 15 square meters. And then the lateral surface area of the legs. We have 4. The lateral surface area is just 2 pi RH. Or in this case, we can just do 4 times pi d, since we're given the diameter, h. So we have 4 pi d is 0.15. We'll just use this conversion again. Meters times 1 meter. And this gives us 1.9 square meters. And to calculate the total, we just add up the calculations. 2.2 meters squared plus 15 meters squared plus 1.9 meters squared. And this gives us 19.1 meters squared. Okay, let's look at a slightly harder problem. We need to work backwards. We're given the surface area, and we're given 2 dimensions. We're not given the third. So this surface area should equal 2 times length times width plus 2 times width times height plus 2 times length times height. So 126 meters squared equals 2, we don't know what L is, and W is 5, plus 2, W is 5, and H is 3, plus 2, we don't know what L is, and H is 3. We'll just leave the units out. We know it's meters squared. This is 10L, plus 10 times 3 is 30, plus 6L. So we have 96 over on this side, and we have 16L on this side. Remember, we add like terms. These are numbers. These are variables with L. So L equals 6 meters. This is meters squared. This is meters. So one of the meters cancels out. So practice your algebra skills to solve these problems. And that completes part 2.